Friends, from now onwards, we will go in detail about each and every component of the automobile. To start with, uh, we will talk about the prime mover, that is the engine. Majority of the automobiles are fitted with the four-stroke diesel engine. So all the latest machines are fitted with the CRDI or other means of electronic injection engines. So the engine subject is having approximately 20 videos which explains in detail about each and every component of the engine. And in this video, I am going to talk about some nomenclature of the engine, that is compression ratio, swept volume, clearance volume, etc. etc. And I am also going to explain about the critical parts fitted in the engine. So from next video onwards, I will be explaining about each and every component in separate exclusive videos. The figure what I have shown here is the 6-cylinder inline cylinder block. These are the cylinders 1, 2, 3, 4, 5, 6. Let us see about the cylinders nomenclature. What is the swept volume, what is the clearance volume, what is the compression ratio, etc. etc. Let us see in this video. This line diagram represents a single cylinder out of 6. So imagine this is the cylinder. Okay, this gray one is the piston. This is the connecting rod. This is the crankshaft. This outer circle is the outer periphery of the crank mechanism when it is revolving. So what is VC? What is VD? What is VS? TDC, BDC? We will see. The 3D view of the cylinder looks like this: piston, liner. This distance is called the bore diameter. This, let us imagine this is 8 centimeter. The inner diameter of the cylinder is the bore diameter. This is 8 centimeters. Let us assume the stroke. What is meant by stroke? The distance traveled by a piston from one extreme end to the other extreme end. So suppose the piston travels from here. When the piston is completely downside, the piston crown will be here. Top surface of the piston will be in this dotted line. So from this dotted line, this is called BTC, bottom dead center. And the piston goes extreme straight, it goes up to here. This is called TDC, top dead center. So if a piston travels once from BDC to TDC or TDC to BDC, it is called stroke length. Okay. Then what is the swept volume? Swept volume, the total volume covered by the piston from one end to the other end. This is the distance, stroke length. But what is the volume? Volume is the total volume covered by the piston when it is traveled from one end to the other end. That is called swept volume. Whatever the volume is swept by the piston is the swept volume. How the swept volume comes? Here. Swept volume is equal to area of the cylinder multiplied by stroke length. To find out the area of the cylinder, we have the cylinder diameter as 8, stroke length we have given 9 centimeters. Okay. So we will see in the next page how it is calculated. Same way, the clearance volume above the TDC line, whatever the volume is not covered by the piston, because piston will not travel beyond TDC. This space is required to compress the intake air and also to act as a combustion chamber. So this particular height is called the clearance height, and the volume covered by this height, which is not swept, where the piston will not reach, is called the clearance volume. Clearance volume is equal to again area of the cylinder into clearance height. What is the clearance height we given here? 1 centimeter is the clearance height. Then what is the next? Total volume. Total volume is nothing but swept volume plus clearance volume. Then what is the compression ratio? Compression ratio is this small volume, clearance volume, divided by the total volume of the cylinder. Clearance volume, the small volume, divided by the total volume cylinder. What is total volume? Swept volume plus clearance volume. Okay. This is stroke length. This complete volume is the up to here, up to TDC is the swept volume. Whatever the above TDC is called the clearance volume. Then the total volume is the sum of both clearance and swept volume, and compression ratio is the clearance volume divided by the total volume. Let us calculate this, how much it comes. See, now how much will be the swept volume of this particular engine? As I said, area of the cylinder into stroke length. So what is the area of cylinder? The formula of area of circle is pi d square by 4. Vs is the swept volume. The formula for the area of the cylinder is pi d square by 4. Pi is 3.14 standard, multiplied by diameter 8, again multiplied by diameter. The product of this completely divided by 4. Again the result is multiplied with the stroke length, which comes to 50.24 multiplied by 9, which comes to 452.16 cubic meters is this particular cylinder swept volume. A cylinder of 8 centimeters diameter and stroke length is 9 centimeters. Its swept volume is 452 cc, cubic centimeters. Then comes to the clearance volume, this top one. Same formula again. This is Vc, read it as Vc, not Vs. Okay. Pi d square by 4 into 1, because 1 is the height here. So pi is standard 3.14, diameter remains the same, and this particular up to here the remains, the only height changes. So when it comes to this one, it comes to 50.24 cubic centimeters. Swept volume is 452 and clearance volume is 50.24. What is the total volume? So swept volume plus clearance volume together comes to 452.16 plus 50.24, 502.4. Next, compression ratio. The compression ratio, as I told you, total volume, that is 502.4 divided by the clearance volume 50.24 comes to 1:10. This is the petrol engine. Normally the petrol engine compression ratio ranges from 1:9 to 1:10. If it is the diesel engine, what we'll be talking now, the diesel engine, the compression ratio varies from 1:21 to 1:25. If the engine has 4 cylinders of this size cylinder, then the volume of the engine is, total volume you have to take, total volume of one cylinder, how much it has come? 502.4 into number of cylinders, 4, 2009.6 cubic meters, say 2 liters. A 4-cylinder engine of this size diameter and this stroke length is told as 2-liter engine. Remember, in the market, whenever we purchase the motorcycle or car, they say 150cc, 250cc, 350cc, or 1 liter. 1 liter is nothing but 1000cc, or 1.2 liters, 1200cc, or 2 liters, 2000cc. This is the some nomenclature of the cylinder, because before discussing or before explaining about cylinder block, it is important to know about these dimensions. Where are the diesel engines are fitted? That is four-stroke diesel engines. Our passenger cars, buses, etc. Then the trucks, goods carrying trucks. Then the agricultural machines. Then the locomotives. So even though we can see majority are electric locomotives, but still many trains are running with the diesel locomotives. Then the construction machines, mining machines, ships, cargo ships, and the passenger cruises, and the diesel generating sets, and some other machines which I have not shown here. All these machines, small or big, are being powered with the compression ignition engine, and majority 99% are with the four-stroke compression ignition, that is diesel engine. When it's come to the size and type of the engines, you can see some of the engine blocks. We can see right from single cylinder engine up to 16 cylinder engine in the diesel engines, 1 cylinder to 16 cylinder. This is the four cylinder engine. This is the bottom side of the engine block. This is cylinder 1, 2, 3, 4. This is the 6 cylinder engine. 1, 2, 3, 4, 5, 6. This, if the cylinders are in line, this is called the inline engine. This is 6 cylinder inline block. This is a 4 cylinder inline block. Then the other configuration is V type. The cylinders are arranged in the V shape. So like this and like this. The angle between the two banks will vary from manufacturer to manufacturer. Generally, it will be around 60 degrees. So this particular one is shown as 8 cylinder. 1, 2, 3, 4, opposite side 4. So the V shape arrangement we can see right from 6 cylinders to 16 cylinders. This is the huge, very big engine, 16 cylinder V type engine, which produces about 9,500 kilowatts power. That is approximately 13,000 horsepower. So you can see the diesel engines in the market right from 5 horsepower to 13,000 horsepower. That is 4 kilowatts to 9,500 kilowatts. You can see how big the piston connecting rod inside the engine will. It looks like this, approximately. It weighs some thousands of kgs. Now we will see the important parts of a diesel engine. For easy understanding, I am showing the illustration of a 6-cylinder inline engine. The cylinder block of the engine can be compared with the trunk of the human body, because the human body trunk, as it accommodates various organs in it, the cylinder block also accommodates many critical components along with it, and every critical part required to run the engine is fitted or attached to the cylinder block. I will be explaining in detail about the manufacturing process, or how it is made, and what are all in it further, like liners, etc., in an exclusive video. Then above the cylinder block, this is called cylinder head. The cylinder head is fitted on the top of the cylinder block. In between there will be a gasket to prevent the leakages of gases or any coolant or any liquid. The cylinder head also contains some more critical parts like valves, valve seats, valve springs, and push rods, etc., will be there this side. Complete valve operating mechanism is fitted in the cylinder head, and we can see in some of the engine models, camshaft also is fitted over the cylinder head, but majority of the engines are fitted with the side camshaft. Then next comes to bottom of the engine. This is the crankshaft. This is the mechanical component which converts the reciprocating motion of the piston into the rotary motion. So this is fitted to the block bottom side with the help of the caps and the bearings, and the front end of the camshaft is fitted with the vibration damper, somewhere timing pulley, and also some timing gears or timing chain. And the rear side of the crankshaft is fitted with the flywheel. The flywheel is a energy storage device, that is the most important one, and it also helps to crank the engine with the self starter. So when we want to start the engine, the self starter will crank the flywheel. This is the flywheel gear, and engine starts rotating. Then when the firing starts taking place, self starter is disconnected. Now crankshaft is over. Next component is the piston and connecting rod. Piston with piston rings will be sliding inside the cylinder, up and down, top dead center to bottom dead center, BDC to TDC. Okay. So the piston contains the piston rings to have the sealing between the liner and the piston, and the other end of the one end of the connecting rod is attached to the piston, the other end is attached to the crankshaft. Next component is the camshaft. Camshaft is considered the brain of the engine. Why it is considered brain of the engine? The camshaft decides which valve has to be opened when and has to be closed when. So this is the critical job. The valves opening and closing has to be done in synchronization with the movement of the piston inside the liner. So in the beginning of the suction stroke, inlet valve has to be open, exhaust has to be closed. During compression, both has to be closed. During power, both has to be closed. During exhaust, only exhaust has to be open and inlet has to be closed. So that timely opening and closing is done by the camshaft. So it is called as the brain of the engine. Then there will be timing chain. So which fixes the timing between the crankshaft and camshaft. Some of the engines are having timing gears instead of the chain. Let us move to the other figure. This is one side of the engine. You can see this is the fuel injection pump, which supplies the high pressure fuel to the nozzles. Okay. The fuel timing and the pressure, everything is developed by this model pump which is fitted in this engine. Then you can see the fuel filter. Same way oil filter will be there somewhere here, which is not shown here. And you can see this is the self starter to crank the engine when you are starting from the rest position. This is the vibration damper. See the other side of the engine. This is the oil sump provided to store the engine oil. It's a engine oil reservoir. See the engine. The other side of the engine, this is the turbocharger fitted to the inlet manifold. Some engines do have the intercooler also. Okay. The purpose of the turbocharger also will be explained in later in detail. Okay. Then this is the cooling fan. This is the water pump. This is the thermostat. And you can see so many other components. So these are all the critical components of the 4-stroke diesel engine. We will see in detail about each and every component in the coming videos. And there will be one alternator which is not shown here. The purpose of the alternator is to keep the batteries charging always. Go through this one page note. In case you have any queries, please contact me through the email.